Good afternoon, dear members of the conference. We present to your attention the results of our study on the topic, Methods for Statistical Analysis of the Results of Monitoring the Avifauna on the Territory of Wind Farms. Wind energy is one of the priority areas in the development of energy-saving resources, so the study of the impact of wind power plants, WPP, on the environmental situation is of practical importance. At present, much attention is paid to the accumulation of information on the influence of wind turbines on changes in the dynamics of bird communities. The main task of monitoring the territory of the WPP is to obtain the quantitative characteristics of birds and the direction of their migration in different seasons of the year. The results of observations in accordance with the recommendations of the Scottish Natural Heritage Foundation make it possible to determine the activity coefficient of birds of the J species in the risk zone of collision with turbines, which is necessary to predict the interaction of birds with rotor blades. The purpose of the paper is to develop an algorithm for the use of statistical methods in the analysis of the results of monitoring the avifauna on the territory of the wind farms in solving the following problems. Primary statistical processing of information on the number of birds of various species, flight altitude, and time of their stay at the observation sites, obtained by the SNH and RAM methods. Correlation and regression analysis to determine the dependence of the number of birds on various factors using the student, Pearson, Fisher, Irwin criteria. Trend analysis of the results of monitoring the wind farm territory based on the student, Irwin, Durbin, Watson, Pearson, and Fisher criteria. In many cases, there is a problem of comparing monitoring results obtained in different situations, as well as when comparing data at two sites or for different seasons of the year. Are two samples, each consisting of NX and New York elements. Let us denote the mean sample values as XA, YAT. The verification of the hypothesis about the equality of mathematical expectations is carried out in the case of a known random variable distribution law at a given significance level Q. Various methods are used to identify the distribution law. As an example, let's consider the use of the Pearson's criterion when establishing the normal law of data distribution for the sample. Let's divide the sample into m equal intervals. Let us denote the number of elements in the k interval as nk. The Pearson criterion is calculated by the formula. In many cases, there is a problem of comparing monitoring results obtained in different situations, as well as when comparing data at two sites or for different seasons of the year. The verification of the hypothesis about the equality of mathematical expectations is carried out in the case of a known random variable distribution law at a given significance level Q. Various methods are used to identify the distribution law. As an example, let's consider the use of the Pearson's criterion when establishing the normal law of data distribution for the sample. Let's divide the sample into m equal intervals. Let us denote the number of elements in the k interval as nk. The Pearson criterion is calculated by the formula on your ecran. During the primary processing of row statistics, it is recommended to analyze the possibility of the appearance of anomalous values associated with technical errors in obtaining data or processing the original information. The rejection of erroneous data can be carried out by the Irwin's method. The method is based on determining the coefficients. The values of lambda I are compared with the critical parameter lambda alpha. Element of the row statistics is rejected. Parameters depending on the sample size for the 5% significance level are presented in table. As an example, we will make a primary statistical analysis of the monitoring results at 3 vantage points, VP, belonging to the territory of the Primorsk 1 wind farm. The site sizes of VP1, VP2, and VP3 were respectively 0,52, 0,862 and 1,232. Observations were carried out during the spring period of the bird migration in 2017. The results of daily registration of the total number of birds N, K, at the K site per 1 kilometer, which flew in transit during the spring migration period, are presented in table. At the first stage, we reject possible erroneous measurements using the Irwin method. According, Irwin's critical value for the 5% significance level with the number of measurements n equals 7 is about 2.4. Coefficients for all row statistics in accordance with the is much less than the critical value. The exception is the measurement n, 2, equals 1.26, which was carried out on April 3, 2017, when lambda I turned out to be 3.1. The results of variance calculations of standard deviations Sx and the Pearson's criteria according to the data, from which the measurement n, 2, equals 1.26 obtained on April 3, 2017 is excluded, are presented. The values of were calculated for 4 intervals, m equals 4. The Pearson's criterion is recommended to apply for large samples. Therefore, the obtained data should be treated with caution. Methods of correlation and regression analysis are a powerful tool in identifying relationships between different parameters or determining the influence of one factor on another. Let us consider two samples x, y with the same number of elements n. The presence of a linear correlation between them is determined by the correlation coefficient. The significance of the coefficient is checked using the student's t-test for q equals n 2 degrees of freedom. If the value of t is greater than the critical value at the chosen significance level q, then there is a relationship between the parameters x and y, otherwise, the dependency is considered not installed. The existence of a correlation dependence allows us to represent it in the form of a linear regression equation. As an example, we will study the possibility of the existence of a correlation dependence between the activity coefficient k, 3, on the total number of birds per 1 kilometer based on the results of monitoring in the spring migration season in the third site of the Primorsk 1 wind farm. The results of the work can be represented in the form of an algorithm developed by us. Step 1. Selection or creation of an information system to ensure the storage of observation results in the form of tables or databases, convenient for systematizing the information received and their subsequent analysis. Examples of such information and computer systems are presented, in particular, in our previously published software tools Birds 3, Windrows. Step 2. Primary statistical processing of the monitoring results, which consists in determining the average values of the statistical series, variances, rejecting the results of erroneous measurements and identifying the law of distribution of random variables using the student, Irwin, Durbin, Watson, Pearson, and Fisher criteria. Step 3. Testing hypotheses about the coincidence of mathematical expectations in a comparative analysis of the number of birds and other parameters that determine their behavior in different monitoring areas and in different seasons. Step 4. Calculation of correlation coefficients between various parameters that characterize the dynamics of ornithocomplexes depending on the accounting method, weather, seasonal and other conditions. Step 5. Correlation regression analysis. Construction of mathematical models that determine the dependence of one parameter on another. Step 6. Conducting a trend analysis to identify the possibility of changes in the number of birds over time or the direction of change in one parameter as another changes. An algorithm for analyzing the results of monitoring the dynamics of ornithological complexes on the territory of wind farms has been developed using statistical methods. The proposed algorithm allows solving the following problems. 1. Carrying out primary processing of information on the number of birds of various species, flight altitude, and time spent on observation sites using the student's t-test, Fisher and Pearson criteria. 2. Construction of regression equations that determine the dependence of the number of birds on various factors using the student's t-test, Fisher and Irwin criteria. 3. Trend detection when studying the time dependence of the number of birds or the direction of change of one parameter as another parameter changes using turning points and the student's t-test, Fisher, Irwin, and Durbin-Watson tests. The proposed statistical methods have been tested in the analysis of the results of monitoring ornithocomplexes on the territory of the Primorsk 1 wind farm. Thank you for your attention.